Inside Building Products, a Siemens podcast that keeps you learning.
Okay, so when you think about fire, what's the first thing that springs to mind? Flames, smoke, maybe the immediate destruction. But what if I told you that the damage from a fire often goes way beyond those initial flames, sometimes forcing, get this, 70% of businesses to close their doors forever? That's a truly unsettling thought, isn't it? Today, we're taking a deep dive into fire safety, but we're looking beyond the usual sprinklers and alarms. We're exploring some really cutting-edge solutions, things designed to protect our most sensitive spaces and, well, our most valuable assets. Our goal here is to unpack why a dry approach to putting out fires is becoming so crucial. What do these advanced systems actually do for you, and how are they safeguarding everything from, say, your critical data to irreplaceable historical records? All without, drowning you in technical jargon.
Yeah, it's fascinating, isn't it, how we often just focus on the visible fire itself. But the reality is the secondary damage may be from the water used to fight the fire, or just the sheer disruption to business that can be far, far more damaging. And it raises a really important question for anyone managing sensitive stuff. How do you fight the fire effectively, but also, crucially, minimize that aftermath? We've got some really interesting material here looking into how companies are tackling these exact challenges, particularly with these innovative residue-free solutions.
All right, forget the flames just for a second. The truly devastating part of a fire often isn't the direct burn. It's that silent ripple effect. We're talking consequential damages, liability claims. These can massively exceed the initial fire costs. Imagine the huge cleanup job. Replacing servers damaged by water, navigating complex legal stuff these costs can cripple a business far more than the fire itself. That 70% statistic, it's not just a number. It means if your company has a major fire, there's a really high chance it won't make it past 3 years. It just hammers home why detecting a fire immediately isn't just about putting out flames quickly. It's about stopping that domino effect, before it becomes an existential threat.
Exactly. And if we connect this to the bigger picture, it's fundamentally about resilience. It's not just about protecting a physical building or a piece of equipment. It's about ensuring business continuity. It's about the ability to recover quickly and keep things running. For you listening, this could literally mean the difference between your critical data being recoverable after something happens or not, or maybe a rare archive being saved from water damage, or your company avoiding that massive downtime and financial loss that could, frankly, lead to closure. It's really about protecting the future, not just that present moment when the fire breaks out.
So, okay, immediate detection is vital. But then what's the best way to actually put the fire out? Our first thought is usually water, right? Sprinklers are everywhere.
Yeah.
But I've heard these stories, situations where water actually causes more damage than the fire did. Is that really a common thing or just like a rare exception?
Oh, it's absolutely true. And it's far from rare in certain places. Think about sensitive electronics like server rooms or maybe priceless documents in an archive. Water, yeah, puts out fires, but it can easily ruin circuits, corrode delicate components, or just drench irreplaceable paper beyond repair. And this is precisely why companies like Siemens have really focused on dry extinguishing or gaseous systems. Their Siemens portfolio is all about this. The core idea is pretty simple, but kind of revolutionary. These systems use natural gases or specialized chemical agents that are completely residue-free.
Residue-free. Okay, that sounds like a huge plus. Because it's not just water that leaves a mess behind, is it? Things like traditional powders or aerosols or foam. Sure, they might put out the flames, but they all leave behind some kind of residue. And that residue can cause significant secondary damage, not to mention agonizing cleaning delays. Imagine your expensive data center coated in like a corrosive film or a historical record soaked in foam. That's not just cleanup. It's a whole new disaster.
Exactly right. The key advantage of dry extinguishing is minimizing that collateral damage. We're talking about places where water and electricity absolutely cannot mix, server rooms, control centers, that kind of thing, or environments like museums and archives where water would just destroy the very things you're trying to protect. Even specialized spots like battery storage, gas turbines, or modular substations often need this kind of approach. And with Siemens, their specialization is really in the mechanical heart of these systems, the cylinders holding the gas, the special nozzles, the gases themselves. And they make sure it all integrates smoothly with the broader fire alarm systems. This focused expertise allows for really tailored, really effective solutions precisely where those traditional methods just aren't suitable.
Okay, so if water's out, what do they use? And you're saying it's not just one magic gas?
No, not at all. It's more like a toolkit. The Siemens portfolio offers different types for different jobs. Broadly, you can think of them in 3 categories: natural inert gases, clean chemical agents, and even some clever gas-water hybrids.
All right, let's start with the natural ones. Inert gases, you said, like nitrogen and argon. How do they work?
Well, their trick is pretty neat. They essentially starve the fire. They reduce the oxygen level in the room just enough so the flames can't survive. But, and this is the clever bit, they leave enough oxygen so it's still perfectly safe for people who might be in the room. No suffocation risk.
Ah, that makes sense. Safe for people, but bad for fire.
Exactly. And because they're inert, meaning they don't react chemically, they don't conduct electricity, perfect for electrical fires or rooms packed with sensitive electronics. Plus, for anyone concerned about the environment, nitrogen and argon are basically just components of the air we breathe. They're eco-friendly, don't deplete the ozone, don't contribute to climate change.
And I read something interesting. Because they're gases, they can travel through really long pipes.
That's another big advantage. It means you don't need huge, bulky storage tanks right next to your critical equipment. You can store the cylinders further away, maybe in a service area, which gives you a lot more flexibility in designing the protection for large or complex spaces. It makes the system scalable.
Okay, interesting. Then there's another natural gas, carbon dioxide, CO2. It also smothers fires. Right. But it's a bit different.
It is a bit different, yes. CO2 is incredibly effective at displacing oxygen. So effective, in fact, that it displaces too much oxygen for occupied spaces. It poses a definite suffocation risk. Also, when it's released, it gets very cold, which can potentially cause thermal shock damage to delicate electronics if the nozzle is too close. However, it's very cost-effective, so it's often a good choice for areas where people aren't normally present. Think inside machinery, certain unmanned enclosures, or maybe where multiple fires might be expected over the system's lifetime.
Got it. So inert gases starve the fire of oxygen. What about the next category, the clean agents? You mentioned Siemens 1230. They work differently.
They do. Instead of primarily reducing oxygen, these agents work on a molecular level to absorb heat. They essentially suck the heat out of the fire, interrupting the chemical chain reaction of combustion.
Wow, okay. Sucking the heat out.
Yeah, it's quite clever. These are often chemical agents, and they're typically stored as liquids under pressure, which means they take up much less space than inert gas cylinders. This is a huge plus for smaller enclosed areas where space is tight, maybe clean rooms, control rooms, places packed with sensitive gear. Like the inert gases, they're electrically non-conductive, they won't harm electronics, and they are safe for use in occupied areas at the correct design concentrations. And environmentally, they're pretty good too. Zero ozone depletion potential and a very low global warming potential, so a responsible choice all around.
And finally, you mentioned a hybrid, gas and water together, like Siemens H2O gas. What's the benefit of mixing them?
Well, these hybrid systems are fascinating because they kind of offer the best of both worlds. They use an inert gas, usually nitrogen, mixed with a very fine water mist. So you get the oxygen displacement effect from the nitrogen and a significant cooling effect from the water mist evaporating. It tackles the fire on two fronts.
A double attack. Makes sense.
Exactly. This makes them incredibly effective across a wider range of fire types. They're also safe for people, safe for the environment, and the water component is obviously inexpensive and easy to refill. These are great for places like libraries, archives, museums, even some flammable liquid storage areas where both smothering and cooling are really beneficial.
Okay, so putting out fires with gas is clever, but it sounds like it brings its own challenges, like engineering challenges. And you mentioned Siemens has some smart solutions for these.
They do. Handling gases under pressure isn't trivial.
Right, like when you release a whole lot of gas into a room really quickly, doesn't that create a huge pressure surge? Like a mini explosion of air pushing outwards? That sounds like it would require massive vents in the walls or ceilings just to stop the room from, well, bursting. That must be a headache for building design. How do they manage that?
That's a very real issue, especially with inert gases which require large volumes. And that's precisely where their constant discharge technology, or CDT, comes into play. It's a patented cylinder valve design. What it does is specifically control the rate of gas release, smoothing out that initial massive pressure peak. It ensures a much more uniform, constant discharge over the required time.
Okay, so it smooths out the big whoosh at the start.
Exactly. And what does that mean for you, the building owner or facility manager? It means those big, expensive, often difficult to install pressure relief vents and the ductwork they need can be significantly smaller, sometimes drastically smaller.
So cost savings and easier construction.
Significant cost savings, yes. And it simplifies meeting building requirements, especially in tricky locations like underground facilities or retrofitting older buildings or complex server rooms. The University Hospital Freiburg, which we can talk about, really benefited from this in their data center expansion.
Okay, that's clever. Now, here's another potential issue I hadn't thought of. Noise. When these systems go off, is it loud?
Oh, it can be incredibly loud, especially the initial discharge from the nozzles. We're talking potentially over 130 decibels.
Wow. And could that noise itself cause problems?
For some things, absolutely. Think about data centers again. Magnetic hard disk drives, the spinning kind, are surprisingly sensitive to intense sound waves at certain frequencies. That sudden blast of noise during a gas discharge can actually generate enough acoustic pressure to vibrate the drive heads, potentially causing read-write errors or even physical damage, leading to data loss.
No way. So you solve the fire only to have your data corrupted by the noise of the solution. That's a nightmare scenario.
It really is. And this is precisely the problem the silent nozzle was designed to solve. It's a specially engineered nozzle that drastically reduces the noise level during the gas discharge. It keeps the sound pressure below that critical threshold known to affect sensitive hard drives. This is why companies like Net.de, who handle vast amounts of customer data, specifically chose this technology for their server rooms.
So it protects the data during the fire event and from the side effects of putting it out. That's thinking ahead.
It's about protecting the whole operation, not just stopping the flames. It provides crucial peace of mind for critical infrastructure providers.
Okay, one more specific area. Industrial machinery. Lots of moving parts, oils, potentially flammable stuff in harsh environments. Do they have special solutions there too?
They do indeed. The Sonorix Aldeco solution is tailored specifically for protecting machine tools. A key part of this is their patented LIFS sensors.
Lift sites. What's special about them?
LIFS stands for Linear Fire Detection Sensors. What makes them unique is their incredible resistance to the kind of stuff you find in machine environments: dirt, oil, coolant, water, heavy vibrations. Traditional smoke or heat detectors would likely fail very quickly in those conditions. These LIFT sensors are designed to cope. They work alongside CO2 or argon extinguishing agents to provide very targeted protection right inside the machine enclosure, detecting a fire at the earliest possible stage and suppressing it quickly, minimizing damage to expensive equipment.
Okay, so we've covered the what and the how, different gases, clever tech like CDT and silent nozzles. What do these systems actually get used day to day? Can you give us a couple of real-world examples?
Sure. Data centers, as we've touched on, are a prime application. They are absolutely critical infrastructure. They're packed with sensitive electronics, and any downtime is incredibly expensive, potentially millions per hour for some businesses. The University Hospital Freiburg in Germany is a great case study. When they expanded their data center, they obviously needed top-tier protection for their servers and, crucially, all that critical patient data. They opted for a Sonorix CDT nitrogen solution. The uniform gas release was important, the safety for any personnel was paramount, and because of building constraints, the ability to use those smaller pressure relief flaps, thanks to CDT, was a huge practical advantage.
Makes sense. Critical data needs that level of protection. Sure. Any other examples?
Another good one is Net.de, also in Germany. They specialize in internet and hosting services. They built a new data center designed to house up to 5,000 servers for their clients. For them, they chose a Sonorix argon solution. And as we discussed, the silent extinguishing technology using those silent nozzles was absolutely key. It ensures that their customers' data and business processes are safe, not just from fire, but also from potential damage caused by the noise of the suppression system itself during deployment. That gives their clients enormous peace of mind.
Right, because their whole business relies on keeping that data safe and accessible.
Exactly. So these examples really show it's about tailoring the solution. There isn't one single answer. It's about deeply understanding the specific risks, the environment, the assets being protected, and choosing the right combination of detection, agent, and technology.
This whole deep dive has really opened my eyes. Fire safety is so much more complex than just, having a sprinkler. It's about prevention, choosing the right agent for the job, some really clever engineering, even thinking about things like noise. But how do you bring all these sophisticated pieces together? Does it all work as one system?
That's the crucial final piece of the puzzle. A truly effective fire protection system isn't just about the extinguishing part. It has to encompass intelligent detection, the extinguishing itself, and often elements like managing evacuation as well. And the real value, the real safety enhancement, comes from how seamlessly all these different parts communicate and integrate. Sonorix systems, for example, are designed to integrate flawlessly with Siemens' own fire alarm control panels, like their Cerberus PRO system.
Okay, so they talk to each other. Why is that so important?
Well, it's not just a convenience, it significantly enhances safety. It means there's constant communication between every device from the earliest warning smoke detector right through to the gas cylinder valve. You, as the operator or facility manager, are kept informed every single step of the way. You get clear status updates, pre-alarm, alarm, extinguishing activated, extinguishing triggered. In an emergency, you get precise information about exactly which room or zone is affected. And the system's overall health and status are continuously monitored throughout its entire life cycle, not just during a fire. This integrated approach dramatically reduces the overall risk profile. It increases the security of the entire protected space because you have total awareness and verified control. It eliminates guesswork.
Right, so it's not just individual components, but a whole communicating ecosystem working together.
Precisely. That holistic view is key.
Okay, so let's quickly recap our deep dive then. We've really seen that fire protection is far more nuanced and frankly more critical than maybe many of us realize. It's about protecting lives, yes, but also physical assets, and maybe most importantly today, business continuity. We explored the power of dry extinguishing, using these residue-free gases, inert gases like nitrogen and argon that smother fires, clean agents like Sonorix 1230 that absorb heat, each designed for specific situations. And we looked at some genuinely ingenious innovations, things like constant discharge technology to manage those pressure spikes, making installations easier and cheaper, and the silent nozzle protecting sensitive hard drives from noise damage during deployment. Who knew? And finally, seeing how the seamless integration of detection, control, and extinguishing is what really delivers that ultimate safety and peace of mind.
And this all leads, I think, to a crucial thought for you to take away. In our world that's increasingly reliant on data, on sensitive electronics, complex machinery, maybe the traditional water everywhere approach to fire safety is becoming, in some critical areas, a bit of an Achilles heel. So the question to ponder is, how might rethinking fire protection, not just as a reaction, but as a truly proactive, integrated strategy that anticipates and mitigates all forms of potential damage, including from the solution itself, how might that change the way we design and protect our most critical spaces moving forward?
That is definitely something to ponder, isn't it? Thinking beyond just the flames. Well, thanks for joining us for this deep dive into the fascinating and surprisingly complex world of advanced fire safety. We hope you feel a little more well-informed and maybe, like me, a lot more curious.